Use implicit differentiation to determine dy dx given the equation x squared plus y to the fourth equals e to the y. So this function is going to be very difficult or maybe even impossible to get y by itself and write it in explicit form. But we don't need to do that. Once we learn the process of implicit differentiation, we can apply that for any kind of function, not just polynomial functions, which are the most common types of implicit problems that you're given. We just follow the same set of rules. So to differentiate this in implicit form, any function of x, we just differentiate as we would normally. So x squared differentiates to 2x. Any function of y, we assume is an outer function. So we take the derivative of the function y to the fourth, which is the outer function, then multiply by the derivative of the inner function, which the best we can do is just express that as dy dx. Then we have e to the y on the other side of this equation. E to the y is an outer function because it's involving y. So we take the derivative of that outer function, which will just be e to the y, it's its own derivative, and multiply it by the derivative of the inside part, which is, again, dy dx. Now let's bring all the terms with dy dx to one side. So I'll write this as 4y cubed dy dx minus e to the y dy dx equals negative 2x. Just changing sides by subtracting terms over. The dy dx can factor out of the left-hand side of this equation. And what we're left with is taking, dividing out the remaining term. So negative 2x over 4y to the third minus e to the y, and there's our derivative.